Hi guys, I am Isa, and today we're going to learn about memory management in C. Okay, so first I'm going to have to include stdio as always, and then I'm going to make int main, and I'm going to put the printf something. So now let me find out my project's gonna do this dog. Anyways, here we're going to learn about memory. So let's say we have a variable. So int v is equal to 5. So we can print integer. We use the size of command to find the size of v. So yeah, it's supposed to be lu unsigned long. A long is basically like a float that can handle more numbers. But yeah, 4. 4 is the size of this. 4 is the size of every integer. So let's say if we do this extremely big number, we can see this error, which shows that this is the limit of integers. That's the limit of 4 bytes. So yeah, if we wanna add integers that are bigger than that, we can use long. Long stores 8 bytes, in which its limit is much bigger. But yeah, it still has a limit. Like for example, this number can be represented by log. Integer lizard was too large to be represented in any integer type. So if you want to do something like this, we're gonna have to split it up into 2. So yeah. So this thing is stored in like 4 bytes in memory. What if we want to allocate memory ourselves? Now there are 2 commands we can use. This function, which only has one parameter, size, and this function, which has a number and sum. We can proceed to allocate memory. So let's say we have int o1 and int o2. So you want to allocate the memory to, like them. So here I can say that o1 is equal to MALOC or whatever, and put the size. The size should be 4 because that's the default for an integer, and o2 should be the same thing. Now let's run it. We're going to have to put these asterisks besides the thing. So yeah, for this you need to include stdlib.h. So now it's done what it needs to do. If you even change it to 5, and it's still going to work. So that means the O1 limit will be bigger than the one for O2. But yeah, O1 and O2 are locations in the memory. So, well, yeah, that's that. But yeah, so we can also use the call OC function, which says, so we only have one variable here, so we're just gonna use the one thing. Use the two thing. But yeah, we don't have one, so there was a one. So let's say you want to reallocate memory, like the memory you put is not enough. So let's use the same example with O1 and O2. So O2, we're going to do the realloc function, which reallocates memory and stuff. So you have to write the size, and then where I like put it. So 5 O2. Now let's run it. Okay, this will be O1. So yeah, you can see this. You can change the size here. So now, this amount of memory has been reallocated to O1. Allocate memory. So let's say this O1 is a chunk of memory. You want to deallocate it. We can use the free function. To let that memory free or whatever. So yeah, some memory will be freed. So yeah. Anyways, in language like C, you have to make sure that you manage your memory properly, or else, well, things like crashes and the bad stuff will happen. So that's what we're going to talk about. These are called memory leaks. So, let's say int q is equal to 5. We're going to have a pointer here. Let's say int, let's call it ptr for pointer, you know. So let's say ptr is equal to call oc, and they're going to say like maybe 100 bytes. Well, yeah, it's supposed to be mol oc, 100 bytes, 100 whole of that stuff. Yeah, it doesn't do 1,000, I could even do that many. But I'll just leave it at 100, or just 10. Anyways, so if I make ptr to point at x, so I can do that with this symbol. Okay, I'm gonna make it to point at q, and the memory here, it's going to be, you know, inaccessible. It's basically wasting. If too much is wasted, then, you know, it's gonna make your computer to crash and stuff. But yeah, the good thing is to freeze the memory, so free PTR. Then all the problems will be solved. So anyway, that's the end of today's tutorial. If you enjoyed, leave a like and subscribe. So bye.